Alright, so this is a quick view of the wiring that has been done to solve this problem. So if you think about the problem in hand, there's really no need for any code, as we won't be executing any logic through the chip. So if you look at the code, it's basically just got an empty setup function and an empty loop function, because we're pretty much going to use the Arduino board just for the power and the ground. So if you look at the wiring, what has been done is there's a connection from the 5 volt of the Arduino to a column of the breadboard. Similarly, there's a connection from the ground to another column of the breadboard here. The wiring is pretty straightforward. We stick in a resistor to prevent an excess overflow of the current through the LED. So you can see the anode of the LED has been connected to the resistor, which goes to the 5 volt, and the cathode has been connected to two push buttons that have actually been connected in serial. Basically the connection goes this way and it goes this way, and finally the terminal of the second push button is connected back to the ground. So you can even view the so if we start the simulation, you can see that the Arduino is switched on, and now we go through the different tests. In the first test, we just press the first button. You can see the LED doesn't glow. Then we press just the second button. You don't see the LED glowing. And I mean, and the initial state is basically both the buttons have not been pressed, and still the LED doesn't glow. Now, to make the two buttons to be pressed simultaneously, we hold the shift key and press a button. You can see the button has been pressed now. That's why the green LED glows here. And then we push the other button. So now both the buttons have been pressed, and you can see the LED glowing. The moment I release one of the buttons, you can see the LED switches off, which means we have wired the diagram correctly, and it matches the problem statement in hand. That's it.